Okay, we're going to go over the notes from today. A little bit. So what we talked about today was solving exponential equations. So let's go ahead and share that screen. Take a look. I'm going to go over the notes we did in class just so we have them. So here's what we got. When we solve an exponential equation, the big deal is you want to get those things where they have the same base, So what the big deal is, I gave you this in class. So please hold on to this. This is a good way to kind of track our finger across and figure out what's the same base. Because what we want to do is get those things in the same base, and then we can actually solve the equation. So in this case, bring it down a little bit, we have 3 to the x equals 3 to the 5. Both of those are to base 3. So since they are already to the same base, I can set the exponents equal to one another and I can solve it if necessary. Well, in this case, I don't have to solve it. X is 5. Basically, it says, if I put in that 5 for x, 3 to the 5 equals 3 to the 5. And that's a true statement. Okay, this next one, 4x equals 64. So this is one of those ones where we don't have the same base. So what we're going to do is we're going to go and look, and what I suggested was look at the smaller base, in this case, the 4 base. So when I look at 4 base and I drag my finger across, hey, look at that, I get 64. It is 4 to the 3rd power. So what that means is I can rewrite this 64 as 4 to the 3rd. So now I have 4 to the x equals 4 to the 3rd. Since they both have the same base, I can set the exponents equal to one another. X equals 3. Okay. So again, if I go back to the original one, it says 4 cubed equals 64. And if I put that in my calculator, I plugged in the 3 for x, it's true. Okay, so a little bit straightforward, but now we're gonna get to a little more complicated. 9 to the x plus 4 equals 27. Well, when I look here, 9 does not have 27 in it. So what I need to do is I need to see if I can find a row that has 9 and 27. If I come up here to the 3, I got a 9 and a 27. 9 is 3 squared, 27 is 3 cubed, 3 to the 3rd power. So what I do is I need to rewrite this. So this 27 is going to be 3 to the 3rd. This 9 is going to be 3 squared. So, 3 to the 2nd power equals 9. But the way I want you to do this is I want you to take out the 9. I want you to put in 3 squared. And then we have that x plus 4. And if you think back to our exponent rules, when we had something that was like 2 to the 4th raised to the 3rd, we did a multiplication. 4 times 3, you did that distributive property, you kind of multiplied. We're going to do that as a multiplication. This becomes 3 to the 2 times x plus 4 equals 3 cubed. Bases are the same. I can set the exponents equal to one another. 2 times x plus 4 equals 3. Distribute the 2. So that becomes 2x plus 8 equals 3. Welcome back to Algebra 1, folks. Subtract 8 from both sides. 2x equals negative 5. Divide by 2. And we find out that x equals negative 5 halves. So basically, if I had put in negative 5 halves here, what I would end up with is it'd be 9 to the 3 halves equals 27. And actually, if you actually typed it in your calculator, you find out that 9 to the 3 halves does equal 27. Next one. 8 times 2x to the x equals 128. Again, we're going to go to our table. We're going to look at, see what base, see if they all have base 2 I can do. And you'll find out that 128 can be 2 to the 7th. 8 can be 2 cubed times 2 to the x equals 2 to the 7th. And the rule that we deal with, so again, remember your rules. X to the 2nd times x to the 5th. We would add those exponents, x to the 2 plus 5. Well, what we can do is the same base, we can add the exponents. It's 2 to the 3 plus x equals 2 to the 7th. Set the exponents equal to one another. 3 plus x equals 7. Solve. Fold this, actually see a little bit more. So 3 plus x equals 7. Subtract 3 from both sides. X equals 4. That's our answer. So again, if I plugged in 4, that'd be a true statement. Next one is probably one of the trickier ones. Let's bring that table back. 1/4 and 32. 1/4 and 32 are my bases. When I look here, I drag my finger across. Oh, 1/4 is a negative exponent. 32 is that positive exponent 5. So base 2. I can actually do this in base 2. So this 32, take it out, becomes 2 to the 5th. to the x plus 1. 1/4 becomes 2 to the negative 2, x plus 3. Set those equal to one another. Because now we have the same base, technically this is 2 to the negative 2 times x plus 3 equals 2 to the 5 times x plus 1. Set them equal to one another. 2 negative 2 times x plus 3 equals 5 times x plus 1. And now this is the multi-step equation. Negative 2x minus 6 equals 5x plus 5. I'm going to subtract 5x from both sides. That gives me negative 7x minus 6 equals 5. I'm going to add 6 to both sides. Negative 7x equals 11. Negative 7x equals 11. Divide by negative 7. Divide by negative 7. X is going to equal negative 11/7. That's how I solve it. Don't worry about the last one. We talked about it in class, but it's not something we're going to deal with right now. We might come back to it a little bit later. So that's basically how you do it. So the only one that's not on there, if I wanted to do an example, is if we had like a division. So let me just show you this one. If it's a division, notice all our bases are the same. If you remember, x to the 5th, x to the 4th, we do x to the 5 minus 4, x equals 1. Same idea here. What we're going to do is 2 to the x minus x, because 2x minus x equals 2 to the negative 2x. Set the two exponents equal to one another. This is a little bit of a special case. X minus x gives me 0 equals negative 2x. The only way that negative 2x can equal 0, divide by negative 2, divide by negative 2, x has got to be 0. In this case, the only way that that would be a true statement is if I had put 0 for that. So hopefully that helped. Please make sure you get those practices done, because when we get around to Tuesday in a couple of weeks, that's what the quiz is going to be on. Please let me know if you have any questions. Have a nice day.